Day 631 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1984, minimum difference between highest and lowest of K-scores. The difficulty level is easy, so don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index integer array nums where nums of I represents the score of the ith student. You are also given an integer k. Pick the scores of any k students from the array so that the difference between the highest and lowest of the k scores is minimized. Return the minimum possible difference. Okay, y'all, so that may seem confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 90, k equals 1. That means we're only allowed to pick one student because it says pick the scores of k students from the array. So, boom, we pick the scores of one student. Explanation says there is one way to pick scores of one student. We pick 90, that's the only score. The difference between the highest and lowest score is 90 minus 90, which is equal to 0. The minimum possible difference is 0. Boom. So this is important. It's important to recognize here that even if we only have one element in the array, that means we just subtract that element from itself to get our output, which is 0. Now, let's take a look at example 2 where we have more than one element. So in example 2, our input nums equals an array of integers 9, 4, 1, 7. This time k equals 2. So we're going to pick 2 elements. The output is 2. Explanation says there are 6 ways to pick scores of 2 students. Boom. So we could pick the scores of 9, 4, and then that will have a difference of 5, right? So we could pick these 2 students' scores. We could pick the students 9 and 1, right? So these 2 students up here, they're going to have a difference of 8. We could pick these 2 students, 9 and 7. Boom. Sorry, y'all, 9 and 7. And that's going to have a difference of 2. Why? Because 9 minus 7 is equal to 2. Boom. Then we could pick 4 and 1. We already did all the students or all the combinations of students with 9. So now we're going to keep going and do all the combinations of students with 4. So we could do 4 and 1. Boom. That has a difference of 3 because 4 minus 1 is 3. So boom, we could do 4 and 7 because we haven't done that combination yet. That's going to have a difference of 3, right? We want the absolute value. Boom, or we could do 1 and 7. That has a difference of 6. Boom, so we want out of all of these possible combinations, the smallest value or the smallest difference we were able to create was 2 with this 9 and 7, right? So that's why we turn 2. That's where this 2 comes from. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we're going to do is we're going to sort the array so that the elements are in ascending order. And this is going to allow us to examine contiguous groups of size k where the difference between the min and max is minimized. So we'll say let sorted equal nums dot sorted, just like that. Boom. Then we're going to initialize the minimum difference to the largest possible integer, and this will be updated as we find smaller differences. But we could just declare a variable called min, and we could just set that equal to int dot max. Boom. Then we need to iterate over all possible contiguous subarrays of length k. The last valid starting index is sorted. It's going to be the sorted count minus k. So we're going to say for I in 0 dot dot open up the parentheses, sorted dot count minus k. We're going to come outside of that. We're going to open up the brackets, and for a window of size k starting at index I, sorted I will be the minimum element, and sorted I plus k minus 1 will be the maximum element. We're going to update min with the smaller of the current value and the difference between max and min of this window. So we're going to say min equals min, open up the parentheses, min comma sorted. So we're going to find the minimum value between min and sorted. Sorry, this should be sorted square bracket I plus k minus 1. Come outside these square brackets, and we're going to say minus sorted of I. Boom, like that. So sorted square bracket I. Then we just need to return the minimum difference found across all windows by coming right here, and we can say return min, y'all. Boom, just like that. Let's give it a run. Let's see. Okay, we have an error. Let's see. Oh, equal white space, y'all. Equal white space. Let's give it a run again. Okay, now let's see what's going on. Just a minute, y'all. I wonder if we have to change this to, I wonder if it's because we can't have two men. So let's get rid of that and see if that does the trick. And it's accepted, y'all. So let's go ahead and give it a, let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.